What happens when two black holes collide? Hook. Imagine two of the most destructive objects in the entire universe, hurtling toward each other at half the speed of light. Two black holes, each billions of times more massive than our sun, locked in a death spiral that has been going on for millions of years. And when they finally collide, the explosion releases more energy in 1 second than all the stars in the observable universe combined. This actually happened, and we recorded it. Part 1. What is a black hole collision? When two black holes orbit each other, they create ripples in the fabric of space and time itself, called gravitational waves. These waves carry energy away from the system, causing the two black holes to slowly spiral closer and closer together. This process can take millions, even billions, of years, but eventually the inevitable happens. Part 2. The first detection. On September 14, 2015, humanity felt something for the first time in history. Scientists at LIGO, the Laser Interferometer Gravitational Wave Observatory, detected a ripple in space-time caused by two black holes colliding 1.3 billion light-years away. The collision happened 1.3 billion years ago, and we only felt it now. The signal lasted just 0.2 seconds, but it changed science forever. Part 3. What does the collision look like? As the two black holes spiral together, they accelerate to incredible speeds, eventually reaching half the speed of light. Space itself warps dramatically around them. Light bends, time distorts, and then, in a fraction of a second, they merge. The resulting explosion is called a ringdown, and the new black hole formed vibrates like a cosmic bell for milliseconds before settling into stillness. Part 4. How much energy is released? The collision of two black holes releases more energy than all the stars in the visible universe produce in 1 second. But here's the strange part. None of that energy comes out as light. No flash, no explosion you could see. All of it is released as pure gravitational waves, invisible ripples in the fabric of space itself, spreading across the universe at the speed of light. Part 5. What happens to space around them? When LIGO detected those gravitational waves in 2015, the detector moved less than 1,000th the diameter of a proton. That's how subtle the ripple was after traveling 1.3 billion light-years. Yet it was enough to stretch and compress the entire Earth by a fraction of an atomic nucleus. The collision literally squeezed our planet, and nobody felt a thing. Part 6. What's left after the collision? After the merger, a single, larger black hole remains, spinning at incredible speed, surrounded by distorted space-time. Any matter caught nearby would be ripped apart and consumed instantly. The new black hole is more massive than either of its predecessors, carrying the combined mass of both, minus the energy lost to gravitational waves. Part 7. How common is this? Since 2015, LIGO has detected dozens of black hole collisions. They happen constantly across the universe. Right now, somewhere in the cosmos, two black holes are spiraling toward each other. The universe is far more violent and dramatic than it appears from our quiet corner of the Milky Way. Outro. We live in a universe of unimaginable violence and beauty. Black holes colliding, galaxies merging, stars exploding, all happening constantly, all around us, completely invisible to the naked eye. And thanks to gravitational wave detectors, we can finally hear the universe speaking. Subscribe, because next week we explore something that will make even black hole collisions seem small.